So chapter 58 is just percent word problems like we've done before. It's just instead of these being presented to us as simple percent problems, they're presented to us as a word problem. The review sheet that I just gave you has some problems like that. Let's see, it starts with number 24. So 24 through 27 is the simpler form of these, but the word problems are exactly the same. We just got to figure out which part is the of and which part is the is. Right? What is our basic formula for these percent problems? It's always some percentage of some whole equals the part. That's our basic equation for any of these types of problems, whether this is a percentage or a decimal or a fraction, right? That's always kind of how we lay that out. And so we're going to try to we're going to read our word problems and make it match this equation. But the diagrams that we learned about are going to help us do that, all right? So when we were doing these percent problems earlier in the, I can't remember which lesson it was, but one of the earlier lessons, we didn't just have you solve the equation, we had you write the diagram, right? With the before and after. So we're going to start with the diagrams this time, and that's what's going to help us write the equation. So we have a problem that says Kathy, John, and Susie have only 20 chickens left. That's a bummer, right? When you get down to that few chickens. Does anybody in here keep chickens? You got some chickens? All right, that's probably
12 chickens.
You have 12 chickens?
No, 20.
Not 20, okay. So 20 would be, 20's like, that's not a bummer to you. You're like, that'd be great, right? Instead of 12. Given the price of eggs right now, this is actually a really great time to be able to have chickens. But they have 20 chickens left. If they began with 80 chickens, what percent of the original flock remain? All right? So we need to make sure that we're clear what our diagram looks like. All right, so we're going to draw our before and after. Our before is always going to be our 100%, right? What is the before amount in this particular problem? They have 20 left now. They began with 80 chickens. So what's the before amount? The 20 or the 80?
80.
The 80 is, right? So this is of 80 right here. Because that's what we're starting with, right? We're going to be left with 20. So this is going to be our after part. Now the way that we draw these is, since this 20 is less than the original 80, then we always draw it like this, where we have our little oval, and we designate a portion of that to be one part, and then we go ahead and write what the other part would be down here. If we've got 20 up here, what number will we have down here? How did we do those diagrams? You guys remember?
It would be 60.
It would just be 60, right? Because 80 minus 20 is 60. So this total number here should always equal whatever the number is at the beginning, right? So we're trying to find in the first part, 20 is what percent. So this is the is what percent part of 80. And then we're going to have some other, what percent. I'm going to write this as a percent symbol. So 20 is some percent of 80, and then 60 is some percent of 80. But we're going to focus on the top part because that's the number that was given us. So the way that we're going to write our equation now is that some percentage, right? What percent of our whole is 80, what percent, I meant to do a times right here. What percent of our whole, which is 80, equals 20? Does everybody see how I'm able to write that down based on my diagram? The diagrams are supposed to help you go straight to this, right? Once you do this, it should be pretty simple. How am I going to figure out what percentage I have? Yeah, divide both sides by 80, right? So those are multiplied together. So if I divide both sides by 80, then what percent equals 20 divided by 80 is, well, that's 1/4, right? So this is just going to be 0.25. And when it's percentages, we always multiply that times 100. And so this is going to be 25%. So do I see that? I should have put right here that this is percent over 100. Just to remind us that we're going to have to multiply it by 100 to get the 25. So 20 is, I'm going to update this then to say 20 is 25%. And if 20 is 25%, then what is 60? Since the percentages have to add up to 100, 60 is going to be 75%, right? Any questions about doing a problem like that? You guys good? The next problem is asking us about thingamabobs. And, you know, I don't even want to say thingamabobs, so we're going to just skip that. And we'll go to the raisins. Ooh, that's gross too. How many of you like raisins? I'm with that chef on Food Network, if you've ever seen him, Ellen for Ellen. He says, for every recipe, raisins are always optional. I say, amen. Oh, that's true. But they have, these guys, Bo and Christy, hide 600 raisins. All right, so 600 raisins. Why would they be hiding raisins? I don't know. Do you guys do that in your home, Alexa? Hey guys, let's have a raisin hunt. Go hide the raisins, kids. I've never heard that. They hide 600 raisins. This is 60% more than they hid last month. I guess maybe the kids aren't wanting to eat the raisins, so that's the idea. They're hiding the raisins somewhere. Is that what the goal is here? I don't know. So this is 60% more than they hid last month. All right, so the question is, how many raisins did they hide last month? All right, now, because of the way this problem is worded, since it says 60% more, that should make us realize that our diagram over here is going to be the one that looks like two ovals that are kind of lumped together, right? It's our peanut diagram over here. And so we know that 600 is 60% more than whatever we had at the beginning. So here's our before part, which is 100%. And we've got 600 raisins over here. This is our after part. And this is 60% more than what we had at the beginning. So what is my percentage that I'm going to write right here? If it's 60% more. 160, right? I'm taking the 100 that we have here and I'm adding the 60 to it. So this would be 160%. Does everybody see that? Does that make sense? And so over here, we're going to find out what was the original amount, right? So what was last month? You can use any variable you want, but we're trying to find what last month was. So 100% of last month is what we have in this one, and the amount over here is 600, which is 160% of that last month value. So who not on the board thinks they could give me the equation that we're going to write down that's going to allow us to solve for last month? Remember, our equation is percent over 100 times the whole. And this may not be the best way to think about it when this value is greater than 100, because your part is really going to be greater than your whole in those cases. And how do you think you would take this equation and apply it to these values? You want to give that a shot? Okay. We've got Will, Alexa, Madeline, or Cooper. You guys are not on the board yet. Anybody want to take a stab at it? As a hint, you get your name on the board just for trying. And here's what we're doing. What is this percent part going to be? Of these numbers that we have here? Huh? You said it. It's the 160, right? That's the only percentage we have on here. So the percent part is going to be the 160. So we have 160 over 100 times, do we know the whole or do we know the part as far as the way this equation is laid out here? Which one are we given? Whole this is the before. Maybe I should write it like this. Maybe this would be a better way to think about it. This is the before and this is the after.
The way you wrote it, you only know the whole, and you're trying to find the part of what it used to be.
I'm trying to find what it used to be. So do you guys see, and like I said, I think this is probably, with our diagram, this is a better way to write it. Do we know the before?
Not yet.
We don't. That's what we're trying to find, right? So we don't know this one. So this is the unknown. So this is where our LM goes. So this is the after, because that's what we do know. That's where our 600 goes. Does that make sense? Now, how would I solve this guy? I've got LM multiplied times a fraction. I want to find out what LM is. How do I get rid of that fraction? We did a problem earlier with a fraction in it. And we said, oh, this is how you do that. Does anybody remember? When you have a variable times a fraction and you want to solve for that variable, how do you get rid of the fraction? You can divide, but when you divide by a fraction, what are you actually going to do? Multiply by the reciprocal, right? You guys remember that? We're going to multiply both sides by the reciprocal of 160 over 100. So we're going to multiply both sides by 100 over 160. So 100 over 160, right? If we do that, this cancels out and this cancels out. So we're just left with LM. And when we do the math for that, I'm just going to have to look at the book and figure out what that was. The final number is 375. We'll punch that in our calculator. So 375 are the raisins that they hid last one. I think that's what this is. This is probably me and my sister when we were little. My mom wanted us to eat raisins and we're hiding the raisin boxes. I think that's what's going on. Maybe mom won't know this. My mom always found out. Just can't escape mom. Yes. All right. Any questions about setting these up and solving these equations? All right. I'll give you a few problems this week to practice that. And our last chapter that I want to cover today is just doing this again. It's what we've already done. All right, so it's rearranging equations before you do your substitution. So in the previous chapter and the problems that you're going to have on the test, they've already solved for one of the variables. But now they're going to give us two equations where they haven't solved for one of the variables. So you might be given two equations that look like this. X minus 2y equals negative 1. 2x minus 3y equals 4. And the directions say to solve using substitution. Solve for x and y using substitution. We can't immediately substitute any of the values of the variables in because neither of these equations are solved for a variable. How do we decide which equation to solve for a particular variable? Like if I asked you which equation should we solve for a variable and which variable should we pick, which one would you say? Yeah?
The one with the x in front?
Yeah, I would pick this one here because we've already got x with no coefficient in front of it. Right? So I would start with equation 1 because if I solve for x here, it just turns into x equals 2y minus 1. Does everybody see that? We add a 2y to both sides and we end up with that equation. So now these are the two equations that we're actually going to think about in our substitution process. All right? So first step, solve for a variable in one of the equations, right? That's what we did. That's step one over here. We go from that to that. We picked that one because it was really easy to solve for the variable. And then the next thing is to take the value of the variable and substitute it into the second equation. So this 2y minus 1, we're going to plug it into x, into that equation there. All right, so let's do that. 2 times 2y minus 1 minus 3y equals 4. All I did was take my value for x and plugged it in for the x in that second equation. Everybody follow that? Anybody not follow that? Let me say it that way. Give me something. Yes? You got it? Okay, good. Excellent. Thank you, Cody. Now what are we going to do? Got this whole side of the room that's not on the board yet. You guys want to help me solve for y here? That's our next step, right? We substitute the value of the variable into the second equation. So this was step 2. Step 3 is solve for the variable in that second equation. So let's do that. How would I solve for the variable in that equation? What am I going to do first? Bill?
The variables, like, I don't know how to say it.
What would you say, John?
Plug in the value of x into.
Well, I've already done that,
Okay.
right? I took the value for x and I plugged it in here. So now I just want to solve for y. What's my first step for doing that? Where am I going to start?
Get rid of the parentheses.
Get rid of the parentheses, right? So I'm going to distribute the 2. Everybody agree? So 2 times 2y is 4y. 2 times negative 1 is negative 2. That gets rid of the parentheses for me, right? I just write the rest of the stuff down. My parentheses are out of the way. Now I'm going to combine like terms, right? So I've got 2y terms on this side here. 4y minus 3y is y. Minus 2 equals 4. Then I'm going to add a 2 to each side, right? And get y equals 6. So I didn't have to divide like I often do to get the variable all by itself. This one, we were already good. So this right here was our step 3. Over there. All right, and that gave us the value for y. Finally, it says take the value of the variable that you just solved for and plug that we solved for in the second equation and plug that into the first equation. So we're going to take this now and plug it back into my first equation. But remember, my first equation is now in 2 forms. I've got the one they originally gave me, but I've got the one that I solved for x. This is the one you want to plug it back into because it's already solved for x. So if I plug in my y there, x equals 2 times 6 minus 1. So this is step 4. And x equals 12 minus 1, which is 11. And I could add a 5th step here that says, write answer as an ordered pair. As an ordered pair if variables are x and y. Sometimes you'll do problems like this where the variables aren't x and y and the ordered pair doesn't make as much sense. But if they are x and y, often you'll see them written as an ordered pair. So then I'm going to write this, since x is 11 and y is 6, I'm going to write it like that. That's my final answer. Everybody good with that? All right. I don't have time to do the entire next problem. This is problem 3. I just want to set it up for you guys real quick and just make sure you're able to follow these steps. And these problems will be great practice even for your test, because if you can do these, the test is even easier because we don't have to do that first step in the problems that are going to be on the test. So we're given this equation. And we're given this equation. All right, first step, which variable am I going to solve for?
Y.
Solve for y in the second equation, right? Sorry. Huh? You're right, yeah. Because it's already all by itself with no coefficient in front of it. So that's the one we want to solve for. So we're going to make this guy y equals negative 2x plus 25. All right? So I solve for y, that's step one. And then I'm just going to take this y value and plug it back into the other equation. So 4x minus 2 times negative 2x plus 25 equals 38. I just took this y value here and I plugged it in for y right there. Don't mess up your signs here. Make sure when you put this in parentheses that you copy all of your signs down correctly, because we've got this negative 2 in the front here, and that's going to potentially cause you some problems. But at that point, you're just doing all the stuff that we've already done, right? You're solving for x in this one, and then you're plugging the value back in the other equation to find what y is. Okay? All right. Any questions?
So we're doing 58 and 59.
58 and 59 will be your homework assignment for this week. But the big things first, I would work on the worksheet. Do the worksheet and do the test. Reach out if you have any questions on the worksheet, and then do these last two chapters. Yes.
Is the worksheet like a study guide?
It is our study guide. Yep. All right. Like I said, if you can ace the worksheet, you can ace the test. Cool. All right. You guys have a good one. See you later.